this is BQ number 2, Unit T, and let's get started with the first question. So, how do the trig graphs relate to the unit circle? Well, right now we're looking at sine in the unit circle. We're going to begin with labeling it where it's positive and negative. So, sine is positive in the first two quadrants and negative in the third and fourth. So, let's say we wanted to graph sine. Okay? So if we graph sine, it's going to look like this. So we just separated them with the first quadrant, separated them with this line right here. So this first, second, third, fourth. Okay, so like in the first quadrant, it's positive. So it's in the positive area, so it's going up. And the second one, it's also positive. And yes, you can see it's still positive on the second quadrant. And when we get down to tangent, it's negative, so it's going negative. Cosine is also negative. And that's how sine is when it's graphed. And so let's go to cosine. So in cosine, it's positive in the first quadrant, negative in the second, negative in the third, positive in the fourth. So the graph should be going up and then down, staying down, and going up. So that's exactly how it goes. Okay, so y is the period for sine and cosine 2 pi, whereas the period for tangent and cotangent is just pi. Okay, so a period is basically when you finish graphing the cosine or sine, like when you finish, like when you see the pattern start all over again. So it takes 2 pi, so it takes the whole circle to start the pattern all over again. So it's positive, negative, negative, positive, and once that's 2 pi, and you go again and again. So as for tangent, first quadrant is positive, negative, second quadrant, third quadrant is positive, fourth is negative. So you can see that the pattern repeats. You don't need to fully go around the circle. It's just half of it. And half of the circle is just pi. Therefore, the period is pi. And sine and cosine are 2 pi. Okay, so amplitude. How does the fact that sine and cosine have amplitudes of 1 and the other trig functions don't have the amplitudes? Okay, so when we were, I don't remember what unit it was, but when you try to find the inverse of, I guess, something greater for sine, and it's greater than, the numbers was greater than 1, you'd get no solution. And that is because sine and cosine can only be, well, it has to be between -1 and 1. So it can't be any larger or any smaller than that. And that is because if we look at our right here, sine and cosine, it's right here, y over r. So sine for what is it? Okay, so sine for, let's say, 0 right now. It's gonna be, let's see, 1 comma 0. Blah. Why don't I write this? Sorry. 1 comma 0. So then it's going to be 0 divided by 1, which is 0. That is why I put 0 right here. So in 90 degrees, when you go around the circle at 90, sine of 90 is 1, and sine of 180 is 0. Sine of 270 is -1, and sine of 360 is 0. And in those numbers, like around that, there isn't a number greater than 1. So that's why when you plug in tangent on a calculator and it's greater than 1, you still get an answer, because it's possible for that, since it doesn't follow the rule for sine and cosine.